All right, welcome back. This is session 2 of the Fundamentals of IPOS class, and this particular session is called Learning the Language Part 1. We're actually going to have 5 parts of this. Learning the language is a substantial part of learning IPOS, so we're going to spend quite a bit of time doing this. So without further ado, let's get going. Remember what I said back in the introduction, that when we learn the programming language, what we're really doing is we're learning the underlying structure, the bedrock that supports everything. We need to understand the programming language so we can do the motion control, which is really why we're doing this to begin with. So we're going to spend some time getting up to speed in the IPOS compiler language, which is very similar to the industry standard language C. So let's move into that. All right, the IPOS compiler language. As I said, it's based on the C programming language, which goes back a very long way to 1972. I was just 3 years old when C was created. C has been around a long time, but it's had great endurance because it's a very popular and effective language, and it's been the basis of many other languages. It's the ancestor of languages like C++, C#, Java, JavaScript, Perl, and Python. So chances are, if you've done any amount of programming, you've encountered a C derivative language at least. And if you're lucky enough to have actually programmed in C, then you're in really good shape because what you're going to be learning here will fit it almost perfectly. The IPOSplus compiler language includes most of the C language components, but it does drop some of them, ones that really wouldn't be appropriate to controlling a VFD. So it's really a subset of the C language, but it's a fairly complete one. If you know any of the C-derived languages, you will have no trouble with the IPOS compiler language, trust me. If you don't know a C-derived language, but you have programmed using some other language, it shouldn't be a problem. You understand the core concepts of programming, which is what's really important. Just pay close attention to pick up the nuances of a C-type language. All right, now very important note here. We will not be covering every single feature in the IPOS compiler language. It's a very thorough, well-implemented language. Some of the features, in my opinion, are not particularly useful, and some, while they're useful, produce code that's very hard to understand, especially by people who are new to programming in IPOS or a C-type language. And my goal in this course is not to have you produce really crafty, clever code that only people who are really in the know can understand. I want you to develop an easy-to-read coding style that other people can understand and get up to speed in very quickly. So we're going to explore what I call the big ideas of programming, and we're going to do it in this way. We're going to start by learning about the basic program structure of an IPOS program. Then we're going to build around that and add additional components. And as I said, we're going to spend 5 sessions doing this. We're going to learn about comments and formatting code so that it's readable and easy to work with. We're going to talk about what's called compiler control, where you put things in your code that really tell the compiler what to do. Then we're going to look at constants and variables. These are both very important because that's how we represent information in our program to control the VFD. We'll be looking at math and logic, how we manipulate constants and variables to do different things. Then we're going to look at the built-in function library. This is sort of like the commands built into IPOS. And these are all very specific to motion control and communication and VFD-related activities. So we will look at the built-in functions. We'll look at decision structures. These are things like if, then, else, which allow your program to make decisions based on values and variables or values coming back from I/O. We will look at looping structures, which allow your program to repeatedly do something, either a fixed number of times or until a condition is met. And then finally, we will look at creating our own functions, what are called user functions. So this is going to occupy us for some time, but when we're finished with this, you'll have a very good bedrock upon which to build motion control applications. So we're going to start with the basic program structure right now, and then move on and look at comments and formatting, compiler control, and so forth. So let's look at basic program structure. An IPOS program begins as a project. Now, a project is just a collection of all the files required to create the finished program. What most people do is they create a folder somewhere, like on their desktop, and they put all the project files in that one single folder, and they all stay together. And then when they're done, they can archive that folder somewhere safe, and it's got everything needed to go back to that project at a later date. Now, what's a project usually have inside the folder? Well, it probably contains at least one source file. These, remember I told you, are just plain old text files that could be created with any text editor. They contain the IPOS code, and they have the extension IPC, probably for IPOS code. All right, pretty simple. There may be header files. These are files that end in .h. And these are optional. You don't have to have them, and many projects don't. But header files are little bits of code that get linked in at compile time, and they can be useful for certain things. There may be some documentation files as well that simply document the project. These aren't directly part of the program. They don't have any influence on it, but they explain the project. So if you've got anything that needs to go with your project that someone in the future would appreciate having, put it in the project folder. And then finally, there is a project file that ties everything together, basically tells the compiler what all the files do and where they are. And it's unfortunately got the extension .icp. Now, if you think about that, source files have the extension .ipc. That is very confusing. I think whoever came up with that long in SEW's past made a big mistake making those two extensions almost identical. But we're stuck with it, we'll live with it. The project file links it all together. Now, you should know that a minimum project just has the project file with the .icp extension and one source file with the .ipc extension. So all it really takes is two files in a folder to make a minimal project. And that's pretty much what we're going to be doing in this class. Almost all our projects will be just like that. All right? Clear so far, I hope? Now let's take a look at an IPOS source file. Remember I said this is just a plain old text file that can be created in any text editor. And this is a shell IPOS source file. It doesn't really have much in it, but it gets fleshed out and turned into a full program. So let's look at some of the pieces that make it up. First of all, we have what's called a multi-line comment. That is just information for programmers to read. It has no influence on the code's execution. It's multi-line because it spans more than one editor line. This one spans 3. Then we have some compiler control lines. These tell the compiler what to do when it compiles your program. And a good way to identify a compiler control line is they all begin with that pound sign. So in this case, it's pound include and then constant b.h in angle brackets. All right, so that's a compiler control. We'll be learning about these pretty soon. We also have some single line comments. These are comments that just occupy one line by themselves. We have the main function. This is kind of like the outer program. The main program, its outer structure, and everything contained below this is the main task that executes. We also have a looping structure. We'll explain why there's an empty looping structure in a basic shell of a source program. This is important. You actually always have this while looping structure in there, and you'll understand the reason in a little while. And then notice there's a lot of curly braces in closing things. In all C languages, blocks of code are enclosed in a pair of open and closed curly braces. And they are there because C compilers have trouble knowing where things begin and end. And so the curly braces kind of indicate where blocks of code begin and end. You're going to use a lot of them. And you always want to get them right. If you have an open curly brace, then you've got to have a matching closed one later in the code. If you have mismatched curly braces, you will get errors when you compile your code. So that is the number one thing you can do to make sure your code compiles without errors. Let's zoom in on a few of these things. We're going to start by taking a look at this line here. The pound include statements are compiler control commands. They tell the compiler what to do when it's compiling the program. Remember, compiling is translating it from the source code into assembly language and then running the assembler to translate it into the executable object code. So this is telling the compiler during that first translation step what to do. In this case, the include command says take a header file. Remember, those are files that end in .h, and just insert it into the code during compile. You can think of it almost like a cut and paste operation. It's sort of automatic cut and paste. It takes that file that ends in .h and it opens it up, pulls the code out of it, and inserts it into your program during compile time. You'll never see that code actually appear in there, but that's what it's doing. It's cutting and pasting it during compile time. And in this case, constant b.h and iob.h are two very important files that should be in all IPOS programs, because what they do is they put a lot of information in there that makes your life easier. Okay, these create shortcuts that make coding easier. Remember in our last module, I said that the system H variables have names. Well, where do those names come from? They're in these files. So these are creating shortcuts to make your life easier. So you always want to include them in your code. So put them in all your programs, life will be good. All right. We're going to look at the core of the program, what's called the main function. Now, what is a function? This is a term you'll hear a lot because programs contain functions. They use functions. Functions do all sorts of things. Functions are blocks of code that perform a specific job. In this case, we're looking at a function called main. And as its name implies, it's the core of the program. It's the main function, but you will often see programs with dozens of functions. The main function contains task 1's startup code. Remember, we said you can have up to 3 tasks running in the Movi Drive B at once, and task 1 is the only one that you must have. Well, main is the part of the program that executes when task 1 starts. So you can see it right there. It's got an empty set of parentheses after it. Most functions do. We'll explain why at another time, but just be aware right now this is your startup code. And it does really 2 things. First of all, it's the very first thing to run. When you start the program in the Movi Drive B, by doing it through MoviTools Motion Studio, it launches task 1 by starting up the function called main. Now, what's main for? Well, typically it initializes the system first. That means it sets variables to specific values. Maybe it configures certain things in the VFD. These are things that have to be put in place at the beginning so that all the motion control can happen afterwards. So that's the first thing it does. Also be aware with main that it runs over and over and over from start to finish. So it runs through all its code, and when it comes to the bottom, it just starts over. Now, if you think about that, that could get you into trouble. Because do you really want to keep reinitializing the system over and over and over? Usually you don't. You initialize it once, and then you do a lot of motion control over and over and over. We'll show you how we get around that problem in just a minute. But before we do that, I want to point something else out. Notice that it encloses all its code in a pair of curly braces, and I've highlighted those there with red arrows. You can see that those enclose all of main's code. So curly braces, very, very common in an IPOS program. Now let's talk about that whole issue of reinitializing the system over and over and over, or rather how to avoid having that happen. We use what's called a looping structure to prevent that from happening. A looping structure causes a section of code to execute repeatedly. And we have a looping structure right here. It's the while one structure that I've highlighted with the red arrow. This is what is called an endless loop, meaning it executes over and over and over and it never stops. So what will happen is main will start up, it'll execute all the code in the curly braces starting at the beginning, and then it'll come to that while one loop, and from that point on, everything in the while loop will execute over and over and over, but nothing else will. That's how we keep the initialization from happening repeatedly. The while loop kind of traps the program into this endless loop so that it's only executing the motion control over and over. So it's there to prevent the initialization code from being run more than once. And when you create an empty source file, it always has that while loop built in there because the designers of IPOS knew that everybody's got to do that, so they put it in there. Notice that the while loop also has a pair of curly braces, and that contains all the code that you do want to be executed over and over and over. By the way, this is just an aside. If a looping structure needs to execute just a single line of code, you don't need the curly braces. You could just put it right below the while loop. But think about this. In most cases in a program, you need more than one line. So, in my opinion, the smart thing to do is always enclose your code in curly braces, even if it's just one line. That way you won't make a mistake later, add a second line, and then break the program. All right? If that didn't make sense, don't worry about it too much. Just when in doubt, use curly braces. All right, time for a hands-on task ahead. We're going to create our first IPOS program. And from now on, when we go into hands-on tasks, you will notice I'm going to include an instruction of whether to create a brand new file, and I've got its name. In this case, we're going to create program 1, or whether to use the program from the previous hands-on task, in which case I'll say existing file. So we're going to use a brand new file here, so this will help you keep track of your files. So what are we going to do? Well, we're going to create an IPOS project and get it ready to go. So here's how you do this. Again, watch this closely. I'm going to outline it, then I'll give you a chance to pause the video, try it yourself, and I'll come back and show you how it's done and you can check your work. So step 1, we need to be in MoviTools Motion Studio, obviously, and we need to create just a regular MoviTools project. You do this anytime you set up a VFD, and if you took the MoviDrive B intermediate class, you know how to do this, so I'm going to assume you do. So what you need to do is create the project and then get connected to the MoviDrive B with your USB interface, either the USB 11A or the USM21A. And I would like you to put this project in a folder on your desktop. You can just call it IPOS if you want, and then create a project in there called IPOS_class. All right, so once you've done that, you've got a MoviDrive project ready. Now we're going to drill down a little further and we're going to start the IPOS compiler. So you go to the VFD where it appears under the network, you right-click on its name, you go to the programming section of that pop-up box and you pick the IPOS compiler online. And that launches the compiler tool. And that will come up and look like this in a separate window. Now, the very first thing you need to do is create an IPOS project. Now, you may be thinking, didn't I just do that? No, you created a MoviDrive B project. That's just a VFD project. What you need to do now is create the IPOS project. That's that file that links everything together and links together the source file. And remember, they both have the extensions that are almost alike. That's what you're doing here. So you go to File, New, and Project. And I'd like you to call the IPOS project IPOS_class_programs. Now this box will come up and you need to put the project name in and specify the project folders. And for the most part, you can just go ahead and use the defaults. You don't have to set too much up in here.
So your project name and folder is here. Just make sure everything's pointed in the right place and that the right name for the project is there, IPOS_class_programs. Make sure it's going into the right folder. Do check that box, create project subfolder. You do want that to happen automatically. Never change this line. You want it just to always point here. Otherwise, you may have trouble when you try to compile. And this points to locations for other files that are generated as you compile. You can just leave those at the default values. That's fine. And then click OK, and you're good to go. So now we have a project. We now need to add a single source file to it. So to do that, go back to File, pick New, and pick Source File. And we're going to call this one program_1. Which is what I told you in the hands-on task ahead screen. So call it program 1. And this will pop up. And what IPOS is offering to do is build you kind of a skeleton program. And it's asking you, what do you want in the skeleton? Well, you should definitely check that first one, the main function. But at this stage, leave all the others unchecked because we're not using tasks 2 and 3, nor are we putting any interrupt code in there. So we just want the basic skeleton with main. So we check just the first checkbox and we check OK. Later on, when you get more expert and you're doing the other things, you can check the others if you like. And it doesn't really hurt if you do. It's just going to put some code in there that you won't use. All right, so check that and click OK and go. And this is what will pop up. You will now have your project and you will have a source file as part of it. And at this stage, you actually could start coding if you want. But before you do that, I suggest you do a little customization of your programming environment so it's congenial to your personal taste. So go to the Options menu and pick Settings, and this allows you to configure the compiler. One thing a lot of people want to do is set up their colors, like their text background and foreground. They may want to color code different parts of the program. This is totally your choice, whatever works for you. I tend to like a black screen with white text on it, and I use green and blue and yellow for certain specific kinds of text. That's just me. It's your call what you do. You can just leave it at the defaults if you're happy with that. You can also change the font, although I would say you never want anything but a monospaced font. This is probably the one time in the universe that Courier New actually gets used because it's a great font for programs. It's monospaced, which means that when you tab to align your code, everything always lines up perfectly. If you use a variable spaced font like Arial or Times Roman or any of the others, things won't line up so nice. So just leave it at Courier. That works well for programming. Then pick the Compiler tab, and you can configure the compiler, how it behaves. What I strongly recommend is you check the Save Automatically before compiling. That way you will automatically have your program saved, occasionally at least, and you're less likely to lose it all if something goes wrong. So that's a smart thing to do. You may notice we've got a line here in German. That happens in SEW's products occasionally. Somebody forgets to translate a line, and of course we are a German company. So what does that mean in English? It means don't download if the unit is enabled, and you can check it or leave it. We'll just leave it unchecked for now. And then finally, you can go to the Execution tab and set the Task 1 and Task 2 speeds. What you should do at this point is set them both to 0, and that will select the default values, which remember Task 1 always takes 1 instruction per millisecond, and Task 2 does 2 per millisecond by default. If you pick that, you pick zeros, you'll get the default. That's what we want at this stage. All right, so you've seen it. Pause the video. Go do it yourself on your demo unit. You'll probably want to go back and look at some of the previous slides just to know what to do. And then when you're all finished, you come back, unpause the video, and I will do it, and you can see how well you did.
All right, so let's go ahead and check out your work. So I'm going to go ahead and dive in and demonstrate all those steps. So here we go. All right, well, let's get this show on the road. We're going to set up to write our first IPOS program. First thing we need to do is fire up MoviTools Motion Studio and start a new project. Now, this is a MoviTools Motion Studio project, not an IPOS project. So we just click New Project and then OK. And I'm just going to call this IPOS class. And I've created a folder on my desktop called IPOS. You can see it right there. So I'm going to put this in there. So I click OK. And now I'm going to scan into my network by right-clicking on my USB adapter and picking Network Scan. There's my Movi Drive B right there. So I'm all set. I'm going to fire up the IPOS compiler and now create an IPOS project. So I right-click again, pick Programming, and IPOS compiler. So here's the IPOS compiler tool, and you can see it's empty at the moment. So what I need to do now is create a project. So this is the IPOS project, which is actually part of the MoviTools project. So I pick File, New, Project, and I'm going to call this IPOS Class Programs. And I'm going to make sure to put it in the right place. So I've got to navigate to my IPOS folder and put it in IPOS class. So there we go. And I need to make sure I've got my Create Project subfolder checkbox checked. Everything else I can leave alone. So there we go. I now have my project. My next step is to add a source file. So I'm going to go up to File again, pick New, Source File. Do you want to add a source file to the project? Absolutely. And I'm going to call this Program 1. And it's already in the right place, IPOS class program, so I just click Save here. And it's going to now give me the option to create sort of a skeleton program, and I'll let it do that. I'll check initialization part. I'm not going to check task 2, 3, or interrupt because we're not using those at this point, so I'll just click OK. And there's my skeleton ready to roll. So you can see it's done a little commenting, kind of laid out a few key things. Not a whole lot in here yet. We'll customize this more later. So we're pretty much ready to start programming. Now I do want to review what I talked about just a second ago. I want to go into the Options menu and pick Settings to show you some of the customizations available. If you wish, you can change your colors for things like your background, your text, and different things like the keywords and directives and comments and other things in your IPOS program. I've set it to what I like. You can set it to whatever you like or just leave it at default. I would recommend you use a default tab size of 2, and I do recommend you use Courier New as your font. Now you notice I've got kind of a big Courier font. That's just to make it easier for you to see. By clicking Change, I set that to 16. You'll probably want to set it to about 12. So there you go. Now let me click the Compiler tab, and I'm going to just check one checkbox that isn't checked by default, and that is Save Automatically Before Compiling. That's just a smart thing to do. And then finally, I'm going to check the Execution tab and make sure both Task 1 and 2 are set to 0. That means they're default times, and that's what we want to keep. So I'm going to click OK. That's everything. The last thing I need to do is just click Save here to save my project. And that's pretty much it. I'm now ready to program. Okay. Well, hope you found that interesting and that it worked well. We're now going to move ahead and learn a little bit more about programming. All right, let's go back to some of the big ideas of C programming. We've looked at some introductory things like the basic program structure. Now we're going to tackle the topic of comments and formatting. These aren't strictly part of the program because they really don't affect how it works at all, but they're very important to making a well-written, easy-to-understand program both for you and other people. So what about comments and formatting? Well, good programmers consider both themselves and those who have to support their code. If you have to go back to a program several years after you've written it, I think you'll be very grateful if you leave yourself a few notes so you kind of understand why you did what you did. And I know whenever I've had to support somebody else's code, I do not feel very friendly towards them if they don't leave me any notes. You will make friends of people you may never meet simply by documenting your code well by good comments. And that's one of the ways we document our code, by putting comments in there. Comments are just simple lines of text. The compiler totally ignores them, but they're just in there to provide information. They also explain what something does or its significance in the overall scheme of things. There's no one rule for creating good comments, but comments should be designed to help people understand what the program as a whole does and often what individual lines do. Another way you can improve your code's readability and understandability is by formatting it. That's the way you arrange the lines on the screen, adding indentation and extra white space. We'll talk about that in just a minute. You should be aware that C does not require any formatting. You could just take your code and turn it into one gigantic line, and the compiler would be perfectly happy. It would compile it, it would run fine, but you are not going to make any friends if you write code that way. So, formatting improves readability, makes it easier for both you and for other people who may have to support your work. Indentation, which is one kind of formatting, makes the program's logic and structure more obvious. You can show where things are subordinate to other things, for example. I'll show you a few examples of that shortly. And I would say when you indent, always hit the tab key to indent, which gives you an automatic 2 spaces. Don't use the space bar. You will get better results. Things will line up well. Now, if you look on the left, you can see a chunk of a program that I wrote, and you notice it's very thoroughly commented. It's also indented. It's got extra white space. I consider this a reasonably good example of a program that somebody else could decipher without too much trouble. Do remember, too, that anything that improves readability is good. We want to make code easy to read and understand. That really is the watchword. Comments come in 2 versions, single line and multi-line. If you want to have just a single line comment, what you do is you put a double slash right in front of it, and the compiler knows that when it sees the double slash, everything after it should just be ignored. But this only works on one line. So when the line ends, the comment ends. A multi-line comment uses a group of characters to identify the beginning and the end of the comment. You have a slash asterisk, and then at the end you have an asterisk slash. And everything between those 2 groups of characters is ignored by the compiler. So this can span many lines if you wish. Now, zooming in on this code, notice first of all that I have created a header to this program. I recommend that you do this. Now, a header should contain these 4 pieces of information: the name of the program, its version, and you should update the version number when you make changes, whoever wrote it, your name, and then just a 1-sentence description of what the program does. Doesn't have to be really detailed, but it should at least identify the function of the program. All right, that's typical. I always put a header very much like this at the top of my programs. I also recommend that you identify major code sections with comments. For example, I've called out the section where I set up my variables and constants. If you look to the left, you'll see I've identified where the system functions are. Each function has a header that says what its name is and what it does. Comments cost you nothing, but they make your code so much more understandable. Another thing you should do is, if your program requires specific parameters in the parameter tree of the MoviDrive B to be set to something, document it in the program's header. So set up a comment right after the header and document the parameters, what they should be set to. This is really important because if your program depends on these parameters being set to something and someone in the future doesn't know that, then your program probably will never work. And they won't know why unless they decipher your program. And again, that won't make you any friends. You should also comment individual lines of code. Now, you don't have to comment every single line, but I recommend commenting the majority of them. And what you should do is not just explain what the line is doing as a piece of program, you should explain its significance or its function. Let me give you an example. This first comment would be a bad one. H1 equals H2 plus 1, and then I put a comment after it, adds 1 to H2 and puts it in H1. That's a stupid comment, and the reason is it explains the obvious. Anybody who knows how to program can figure that out. You don't need a comment to explain how the language works. What I want to know is, why am I adding 1 to the H2 variable and putting it in H1? What's the significance in the context of the program? This is better. H1 equals H2 plus 1. Another bottle is on the pallet. Okay, that explains something. It says this is a palletizing application, and what I'm doing is I'm counting bottles as they're going on the pallet. So this is a counter, and probably that counter is going to be used to make a decision when the pallet's full. So see, that is better. It explains what it means, not what it does. So try to make your comments work like that. Don't just explain how the language works. Give your future self or other people the benefit of the doubt that they know how to program. Now, we can also use formatting to make our code more readable. I've blown up the main function here, and you notice that the code isn't all just lined up like a ruler goes down the left side. It's indented to different levels. By indenting code like that inside of curly braces, what I'm doing is showing that code is subordinate to that associated structure. In other words, I'm showing relationships by indentation. Now, you don't have to do this, but almost all good programmers do, because it really improves readability. And I think within 10 minutes of doing it, you'll appreciate it. You can also indent lines of code under other control structures even further in. Again, it shows additional subordination. Remember, use tabs to do this, and that really is going to gain you something. Also, I recommend using some white space, just extra spaces, to make code more readable and less claustrophobic. Now, you can't always do that if you have really long lines with very dense code, but like the example I've outlined in red, there was room, so I used some white space. Good idea. Time for a philosophical point about programming. C gives you countless ways to show other people how clever you are. Most of these produce code that's very hard to read and understand. So, my recommendation is that unless you're hanging around with certain kinds of programmers who think this is cool, these coding styles won't earn you any friends. Good programmers make life easier for other people. They don't show off with their code. If you really like to show off with your programs, there are venues for that, but this class is not one of them. So, here's my goal. Readable and easy to understand code is our goal in this class. So I'm not going to be discussing those obscure, clever features of C coding. I just want you to write very readable, easy to understand code, and that's the long and the short of it. Because C is a free format language, you need to tell it when a code statement is complete. Remember I said you could just smush C code together? Well, C code still needs to know where the individual lines begin and end, even if you smush it all together. So we put something in there to make it clear where things begin and end. And that thing is the semicolon. You notice there are a lot of semicolons in here, usually at the end of lines. There's one right there. These indicate where lines end, and the compiler uses those to figure out where everything is. If you forget a semicolon, you'll probably get some kind of weird compile time error when you try to compile your program. So that is one of the most common errors. And if you just try to be sure you're meticulous with the semicolons, they won't happen. But if you get a weird error, that's one of the first things to look for. Unfortunately, some structures do not need semicolons because the end is obvious to the compiler. So you don't use them 100% of the time, which makes life a little harder when you're learning. Notice, for example, this while loop does not have any semicolons associated with it. The individual lines of code in the curly braces do, but nothing after the curly brace, nothing after the while. The reason is this structure is obvious where it begins and ends. The while statement indicates it's a beginning. the closing curly brace makes it very clear that's the end. So there are some exceptions. And I'm going to discuss these as we go along. Okay, so don't worry, you'll get very adept at knowing where to use the semicolons. All right, very good. Let's talk about compiler control. We've already talked about it a little bit. Let's talk about it some more. Now, I've pointed out already that compiler control lines come early in the code. They're really not part of the C language. They're actually just instructions to the compiler when it's doing that translation step, telling it how to behave. So they're telling it what to do as it runs. And there are a whole bunch of them. We've already looked at the include compiler control statement. You can see a few others here called define down lower. We'll be learning others as we go along. They always begin with a pound symbol and then the word right after them, no space. And they never end in a semicolon. So compiler control lines do not require semicolons. So there's one of our exceptions right there. So notice no semicolon after that define. We will discuss the various ones as they come up. Okay, a hands-on task ahead. We're going to do another hands-on. Notice we're still using the program 1 file that we set up a while ago. So you're not changing to a new file yet. So probably it's open on your computer right now and you can just dive in and use it. Here's what we're going to do. This is your first program. I want you to customize the standard skeleton program to look something like this. Notice I've modified the header so that it has those 4 lines I recommended. I've also put in the variables and constants and user functions, kind of just stuck that in with the rest of the existing skeleton code. I want you to customize it to look sort of like that. We're going to use this over and over and over in this class. So you can make it a little bit personal if you wish, but something along these lines. Then I want you to type this code in exactly as it's written. So I'm not giving it to you as a file you can cut and paste. I want you to get some practice using the editor and indenting and doing various other things. So you'll probably have to pause on this screen while you type it in. And hopefully if you do it right, we'll later compile it and it'll run just fine and you can see what the mystery program does. So that's what you're going to be doing. Once you've done that, we're going to compile it and run it. So I'm going to show you how to do this before I turn you loose and let you do it. This is, of course, the compiler screen. And I want to point out a few of its features. Notice, first of all, we have 3 red status indicators. These tell us what the 3 tasks, tasks 1, 2, and 3, are doing. Right now, they're all stopped. They're in P-stop. That means programs stop. They're red. So that means nothing is running, but they will change to green when the tasks run. And if a task isn't running, it'll stay red. We also have your usual file operations for saving and opening programs. We have a few buttons to compile the code. We have also ones that compile the code and then load it into the VFD. And we have the run and stop to start and stop task number 1, which remember I've told you is always started and stopped through MoviTools Motion Studio. Here's where you do it. Now, what's the difference between the different compile buttons? Well, one of them compiles just the current source file that's open. It is possible to have a program with several source files, so maybe you don't want to compile them all because that takes longer. However, what I think is better is just compile the entire project. It doesn't take that long and it makes sure everything gets compiled. So the second choice is a better one. On the other hand, what I think is really better is to compile it and then load it into the VFD so you can test it. So again, we have one that compiles the current source and loads it, and one that compiles the current project and loads it. My opinion is this is the one you should always pick, because that's really what you want to do 99% of the time. Okay, so I recommend that. Just ignore the others. And if you get a successful compile, you'll get a screen like this. It says everything's bright and beautiful. It'll also show you how much memory was used and how long it took to compile, and it'll even throw in a little German just for fun. On the other hand, if you get an error, it will usually try to highlight where it is. It's only approximate, so don't treat this as ironclad. You might have to look at the line above, and it will give you a brief description of what it thinks is wrong. All right, sometimes figuring out what the compiler's unhappy about is challenging. In this case, I just misspelled a word in there. So if that happens, fix it, try another compile. When you get a clean compile, you're ready to go. It'll load it into the VFD and you can run it. Now, once you're ready to go, click the lightning bolt, and that will fire up task number 1. And as soon as that happens, task 1 will start running, and the status indicator will change to show that task 1 is running. It'll change green like this. It'll say start, and that means you're good to go. And if the program later starts the other 2 tasks, they'll change too. And then if you've got a running program and you want to halt it, click the stop sign, and that will stop the program. So it halts all running tasks, all 3 of them if they're all running. And the status indicators will change back to red to indicate that everything is stopped. Pretty simple. You'll do this a bunch of times in this class, and it'll just be second nature in a few minutes. All right, time to pause the video and do the things I said. Customize the template, type in the mystery program, save it, compile it. But before you click the lightning bolt and run it, I want you to do one thing first. Make sure all the switches on your control box are in the off position. Then click the lightning bolt to run the program. And finally, take switch DI10 and turn it from the off position to on and then back to off. That will signal the program that it can go ahead and do its thing, and then you can see what it does. So go ahead, pause, do that. You probably want to go back and look at some of the previous slides, and then once you're happy, you can come back and I'll do it, and we'll see if everything worked for you. All right, well, let's see how you did. Hope that was fun. Hope you figured it out. Let's dive in, and I'm going to do it, and we'll see if it matches up with what you did. Well, here we are. We're ready to customize our skeleton and also put in the mystery program. Now, I'm sure you don't want to watch me type this character by character, so through the wonders of cut and paste, I'm going to speed this up a little bit. So I'm going to first of all customize my skeleton as I suggested to you. So I'm going to kind of get rid of some of the stuff that IPOS automatically generated. Notice I've created my program header, and I've set this up as program 1. I put my name there, put today's date and the purpose, and this is just the first IPOS program. I've also put in this required parameter settings because remember, if parameters have to be customized for the program to work, you should document that in your program. Then, of course, we have those 2 includes, so we just leave those alone. I am going to get rid of this note here. Doesn't really apply to what we're doing, so I'm going to get rid of that. And now I'm going to put in another comment. This is one I put in all my programs. I put a variables and constants comment here so that variables and constants, which will come down right here, will be clearly identified. I'll go ahead and leave this comment, main function IPOS entry. That's perfectly fine, but I am going to get rid of these comments here in the main function. Tidy that up a little bit. So I've got my main function, I've got that while loop in there, and that is it. One more thing, and then we've got our template customized. I'm going to put in a comment to identify user functions because eventually we're going to be putting code that we create ourselves down here. And I want to document that as well and call it out. So there we go. This is basically our customized skeleton now. We're going to be using this throughout the remainder of the course. And as you create new programs, of course, don't forget to go into the header and change the name and the description. Okay, well, that's the first step. Now, the second thing was to key in the mystery program. And I know you don't want to watch me key that in either, so I'm going to, again, just cut and paste it in place. But of course, you need to actually do that yourself. And that'll give you a chance to get comfortable with the editor, remember to use tabs, not spaces, to do the indentation. There's the code. Looks good. So let's go ahead and do a trial compile to see if I made any mistakes or if it compiles cleanly. So I'm going to click this button here, the compile button. Now you may be thinking, wait a minute, didn't you say click compile project and load? And the answer is yes, I did. But I want to click this first just to do a trial compile so you can see it work. And then from then on, we're going to be using the compile project and load into VFD. So I will click this and I get this nice happy screen that says everything is good. Notice it says status OK. That means I had a successful compile. I didn't make any mistakes. So I could OK that. Let me show you what will happen if you make a mistake. I'm going to delete a semicolon here, which should be enough to keep this from compiling. And I'm going to click this again, and boom, I get error, and it flags that line, and it says there's a semicolon problem. So that's what you would see if you had some kind of a mistake. You'd see a red line showing the approximate location of the error, and you'd have some kind of message. Now I'm going to put my semicolon back here. And now we're going to do what you'll do from now on. We're going to click right here, compile and load project. This will compile the project, and if it successfully compiles, it will then transfer it into the VFD's program memory. Of course, if there is an error, you'll get an error screen instead. But since we know we have a clean piece of code here, we can expect it to load, and indeed it does. And this blue bar here indicates it's now ready to run. This is the line of code that will run first. So what I'm going to do now is click the lightning bolt here, which will start task number 1, start the mystery program running. So I will click the lightning bolt, and you notice that the first p-stop changed from red to green, and now it says start. That means task number 1 is running. Now looking at my control box, nothing is happening at the moment. But remember, I told you you had to switch DI10 from off to on to off again. Now I have all my switches in the off position at the moment, so I'm going to go ahead and flip that switch and see what happens, and I'm going to turn on the camera so you can see what happens. So here we go. All right, that was super exciting. We had a bouncing ball. Basically, we had a light that ran back and forth between DO13 and DO17 a number of times, and then it stopped. And I'm not going to do it, but I'll just tell you, if you turned DI10 from off to on to off again, it'll repeat. So not the world's most thrilling program, but still it confirms that everything is working, and that's kind of what we want to do. All right, well, let's stop the program. I'm going to click the stop sign here, which will halt all the running tasks. You notice the status indicators are all red again. And I'm also just going to click my save button to save my project. Always smart to save periodically. And that is pretty much it. That is our first IPOS program. So we have successfully entered it, compiled it, run it, and confirmed that everything's working. So good job. All right, well, hopefully that was good. That was your first program. We're almost done with this session, just a few more remarks, and we are finished. So here's something I'd like to say before we go any further. Most of the programs we'll be writing in the next few sections will involve switches and blinking lights. And the reason is MoviDrive B doesn't really have many ways to interact with you at the basic level. So we're going to be doing a lot of switches and lights programs as we get our feet wet. Of course, eventually we're going to be spinning the motor and doing fun things with it, but don't let that deter you. It's just the MoviDrive B has a very limited user interface, so we can't do really fun things with it. It will get more interesting as we move deeper into the language features and especially the things you can do with it, motion control. And then time for one final point, very important point. In programming, there are many ways to accomplish the same goal. What I do in my example programs is not the one and only way. There's not just one right answer in most cases. Usually there are several. So the way I'm showing you, if it doesn't align with what you do, but if what you do works, fine. Two programmers may take entirely different paths to the same destination, and that is perfectly fine. So, with that said, we're going to end session number 2, and I will see you in session number 3 as we learn more about the IPOS programming language.